Hi everyone. Today I'm going to show you some of the functions of a single phase rectifier, and we'll use a sine wave for our base signal. And it would be a good time to go back and look at some of my other videos about how to chart a sine wave in Excel if you don't already know how. But anyway, what I've done is I've listed the degrees, converted them to radians, and then I've turned that into a sine wave, and then I've created a half sine and a half rectified and a fully rectified sine wave. So the two types of rectifications I'm going to discuss are just a diode, which will give us more of a clipping, something that you would like to maybe count pulses or cycles if you had a reluctor wheel, something creating both positive and negative sine wave voltages. You may only want to be able to detect the positive voltage, the zero and less or negative voltages may not mean much to you. And the other one will be the full wave bridge rectifier down here on the bottom. So as I stated, this diode here for a just clipping, the way it's going to function is if you have a positive voltage on this side of the diode and a positive with reference to the voltage on this side of the diode, it's going to turn on and conduct. As soon as this side of the diode, the top, becomes negative with reference to the bottom side of the diode, then it will stop conducting. And really, this would be used in a circuit if you had an AC sine wave voltage, maybe like what you would have in a receptacle in your house. And you'd have one leg connected to this side of the diode, the bottom side of the diode connected to your load, and the other side of your load connected back to your neutral or the other side of your single phase source. And if you did that, you'd end up with a wave that looks like this gray wave here, where we have a voltage that follows the exact same sine wave input for the positive, but then it goes to 0 volts during the entire second half of the cycle that's all negative. Let me go ahead and remove that. And you can see. So now if you had a high-speed counter, something that was able to detect each of these pulses, you could say, okay, there's 3 pulses in any given amount of time, and you may be able to do something like detect the speed of rotation, the RPM of whatever device you are measuring. Pretty neat device. So the next rectifier, the full wave bridge rectifier, will do something where it actually flips the negative side of the sine wave to be positive, and you can do some other things with that. So let's go back to our sine. The full wave bridge rectifier, whenever you have a positive voltage from your AC sine, represented by this red line here, and it's positive with reference to this neutral wire, this white wire, it will conduct through this diode, and it will conduct through this diode on each positive half of a sine wave cycle. Then on this blue output wire and this, you will see a positive half sine wave here with reference to this voltage. When the sine wave goes negative, you will see this diode and this diode conduct, which means that the voltage on this incoming red line is less than, with respect to, but less than this neutral wire. So current flows out here through your load, back in through here, and back to the source in that direction. And that wave looks like this. So now we've taken and flipped every portion of the sine wave to be a positive. And what that allows us to do is it helps us to reduce ripple and get a smoother, higher, ultimately DC voltage. And this is how a lot of lower end power supplies will function. They'll take the sine wave, fully rectify it, they'll stick some capacitors after that, and you'll end up with this DC wave that charges and then discharges, charges and then discharges, but it'll be a much higher voltage with reference to the neutral where we're looking here. So if you have any questions, feel free to comment below. Don't forget to like or subscribe to my videos, as I'll continue to to post more videos about general Excel knowledge or electrical knowledge. So thanks a lot.